In 2003, 7 astronauts died because one piece of foam damaged a heat shield. Today, NASA launched 4 astronauts on the most powerful rocket America has built in 50 years, on a heat shield with the same known flaw, and hoped the math works out differently this time. And scientists are scared. The kind of scared where they've already seen what happens when things go wrong, and they're watching the same warning signs show up again. Here's what nobody's talking about. Artemis II isn't just a moon mission. It's a 10-day test to find out if America's new space hardware can actually keep people alive. 250,000 miles from home, with no rescue plan if it can't. And there are at least 4 things that could go catastrophically wrong. Subscribe to Space Aquarius and let's begin. The last time America sent humans anywhere near the moon was December 1972, Apollo 17. Gene Cernan stepped off the lunar surface, climbed back into the module, and that was it. Over 50 years of silence. Now NASA is trying to go back. The program is called Artemis, named after Apollo's twin sister in Greek mythology, the goddess of the moon. And Artemis II is the first mission with actual people on board. The crew is 4 astronauts: Commander Reed Wiseman, pilot Victor Glover, who will become the first black astronaut to travel to the moon, mission specialist Christina Koch, the first woman to make this journey, and Canadian astronaut Jeremy Hansen, the first non-American to fly to the moon. These 4 are riding inside a capsule called Orion, which they've named Integrity. The mission itself is not a landing. This is a dress rehearsal. A 10-day, 600,000-mile round trip that loops around the far side of the moon and comes back home. The whole point is to prove that the rocket, the capsule, the life support, the navigation actually works with human lives on the line. And that's exactly where the fear comes in. Here's something that should make you sit up straight. The last time Orion flew, on the uncrewed Artemis I mission back in 2022, it came back damaged, not a little scratched up. The heat shield, the thing that stands between the crew and temperatures approaching half the surface of the sun, came back with chunks missing. Over 100 places where the material had cracked and broken off in ways engineers had never seen before, even though this same material was used on Apollo capsules decades ago. NASA investigated. What they found was that gases generated during the intense heat of re-entry were getting trapped inside the shield material. Normally, those gases vent out through the charred outer layer. But this particular batch didn't have enough permeability, meaning the gases built up pressure until the shield literally cracked from the inside out. Now here's the part that should get your attention. The heat shield on Artemis II? It's essentially the same one. NASA decided not to redesign it. Instead, they changed the angle of re-entry, a steeper, more direct descent that reduces the time the shield is exposed to peak heat. The idea is that less exposure time means less gas buildup, which means less cracking. John Olivas, a former NASA astronaut who sat on the independent board that investigated the damage, called the original shield deviant. He said it was not something NASA would want to give its astronauts. And astrophysicist Jonathan McDowell from the Center for Space Environmentalism put it plainly, you make it thick enough that it hasn't all burned away by the time you've slowed down. And if you get that off by an inch, you're in big trouble. There is no contingency plan if the heat shield fails on re-entry. But the heat shield isn't even the thing that worries McDowell the most. There's something else. Something that's never been tested with actual human beings breathing inside it. And the crew will be depending on it from the moment they leave Earth's orbit. The Orion capsule has a life support system. It controls the air the crew breathes, the temperature inside the capsule, the pressure, everything that keeps 4 people alive in the vacuum of space for 10 days. Here's the problem. Never been run with actual people inside it in space. They've tested it on the ground. They've run simulations. But as McDowell pointed out, they've had the life support system sort of tested out, but never with actual people breathing it in space. Now, McDowell isn't losing sleep over this one. If something goes wrong with life support, the timeline for dealing with it is hours, not seconds. The crew could potentially troubleshoot, fix the issue, or in a worst case, abort and come home early. But here's what makes this different from a problem on the International Space Station. Artemis II is going 1,000 times farther from Earth than the ISS. There's no quick ride home, no emergency supply run. If something goes wrong out near the moon, the crew is on their own. And then there's the sun. Most people don't think about this one. But the moment Artemis II leaves low Earth orbit, the crew loses something they've always had. Something that's been protecting every human being who's ever lived on this planet. Earth has a magnetic field. It acts like a giant invisible shield, deflecting the most dangerous particles the sun throws at us. Every astronaut on the International Space Station is still inside that protective bubble. Artemis II goes beyond it. Once the crew crosses out of low Earth orbit, they're exposed to deep space radiation, the kind that raises cancer risk and, in extreme doses, can cause acute radiation sickness. McDowell says under normal conditions, the exposure is manageable. He compared it to taking a large number of long-haul flights. Not ideal, but not immediately dangerous. The wildcard is a solar event. The sun goes through cycles of activity, and right now we're near a solar maximum, one of the most active periods in the sun's 11-year cycle. That means the chances of an X-class solar flare and a coronal mass ejection, a massive burst of plasma and magnetic energy from the sun, are higher than usual. Even with a moderate solar flare, McDowell said, you might get an exposure to radiation that ups your risk of getting cancer later in life by some significant fraction. NASA monitors space weather constantly and can give the crew warning, but they can't stop a solar storm, and they can't turn the spacecraft around fast enough to outrun one. Here's one more thing, and this one almost stopped the mission before it even started. In February 2025, during a fueling test called a wet dress rehearsal, engineers detected a liquid hydrogen leak in the rocket. The mission was delayed. Then, after a second successful fueling test in February 2026, engineers found a helium flow problem deep inside the upper stage of the rocket, in a section that can't be accessed while the rocket is sitting on the launch pad. NASA had to roll the entire 98-meter rocket back into the vehicle assembly building for repairs. That's like rolling a 32-story building back into a garage. Hydrogen is the smallest molecule in existence. It finds gaps that nothing else can find. And as McDowell explained, it's a beast to stop the leaks happening. Budget pressures and tight timelines meant engineers never got the chance to fully solve the underlying problem. So here's where we land. 4 real risks. A heat shield that came back damaged last time. A life support system that's never been tested with people in deep space. Radiation exposure beyond Earth's protective field during a solar maximum. And a rocket with a documented history of hydrogen leaks. Does that mean Artemis II is doomed? No. McDowell himself said he has confidence in the team. John Honeycutt, the chair of the Artemis II mission management team, said NASA's job is to think about everything that can possibly go wrong, make sure they've addressed every single one of those risks before the crew ever leaves the ground. And the mission has historic stakes beyond just the engineering. Victor Glover, Christina Koch, Jeremy Hansen. These aren't just astronauts, they're firsts. The first black astronaut, the first woman, the first non-American to travel to the vicinity of the moon. But here's the truth that every honest engineer will tell you. This is only the second flight of a brand new rocket. The first time it's ever carried people. And it's going farther from Earth than any human has traveled in over 50 years. As McDowell put it, the team has a lot of experience, but they haven't done this in a while. So it's going to be interesting. And if Artemis II succeeds, if all 4 of those astronauts splash down safely off the coast of San Diego, it doesn't end there. Because what comes next is even more ambitious. NASA's plan for Artemis IV involves actually landing on the moon's south pole, a region of permanent shadow, extreme cold, and potentially billions of tons of water ice that could fuel the next century of space exploration. That mission has its own set of problems. And the spacesuits designed for it? A former NASA astronaut said they're still not great. We'll get into all of that in the next video. If this got you thinking, hit subscribe so you don't miss it. Drop a comment below. Tell me which of these 4 risks worries you the most. And if you know someone who's into space, share this with them. They'll want to see it.